Hello, linear algebra student. This video is for chapter 4.7. So we'll skip over 4.5 and 4.6 and for the time being, jump directly from 4.4 to 4.7 because we're talking about a new basis for a vector space. In 4.4, we say if we have another basis B and we want to write it in based on this, our notation was x of based on B, right? The relationship between the old standards, the standard matrix notation is the change of base for, matrix times x of B, right? And if you want to find x of, actually it should written as not like this outside, right? So if you want to find this, you actually just do the, if you want to find this change of base, basically you solve the equation of P of B, x of B, which is the unknown, equal to your standard notation, and then you can find it. And if you have this and you want to find the original standard base notation, you just multiply, right? So that's what we left off in 4.4. In 4.7, we are actually looking at the two bases for the same vector space V. For example, in a vector space of two dimension, the basis would have two vectors. So the first one is called B. The vector space basis is B and consists of B1, B2. The second one is called C. It consists of two vectors C1, C2. So if I draw B1 like this and B2 like this, you can see that this particular vector X can be represented by 3 times of B1 and then up B2, right? So we can write at 3, 1. And then if you look at the same space, but represented in C1, C2, but where C1 is like this, but C2 is in the positive direction. So to represent this, you basically have to say, well, I go 4x1 and then, no, 6x1, 6c1 and then 4c2. So the I should say this is not x. This is x based on B, right? And this is x based on C. Is equal to 6, 4. So so what happened if I wanted the so they are represented different. So how do I change between them? Say for example, I have another point here, which is what is it? 7 or also 4. What would it be if I want to write it in terms of B1? So to find the connection of these two coordinate vector bases, we want to know how B1, B2 can be formed from C1, C2. So I think the connecting things between them would be in the past we have X is equal to P of B, X of B, right? And then X is also equal to P of C, X of C. If I want to connect between them, what do? I would say, well, I'll just equal them, right? So we'll say P of B, X of B, is actually equal to P of C, X of C. So if I want to write X of a vector only in terms of X of C, so I would say X of C would equal to, just get rid of this, right? With P of C inverse, multiply the inverse in the front, times P of B times X of B. And practically speaking, this just mean, this is P of B. This just mean change your base, change of your bases in B that represent B in the C notation. So this is actually write out all your B1 in terms of C and all your P2 in terms of C, etc., and then multiply to X of B, and that will give you X of C. Oh, I multiply outside. So yeah, you know what I mean. I tend to write it inside. So we have this notation. So this particular matrix is a matrix. It's called the change of base matrix, and we have theorem 15 that say if you want to change base from B to C, you have X of B. You want to write it as X of C. You would multiply with a change of base matrix from B to C because you have B already, you want to change it to C. And it's very strange to write it backwards. So instead of writing B to C like that, the arrow is backwards. So it's written as C, B to C. So you're changing your coordinate from B to C, so you end up having the C coordinate. So whereas the column of B to C are the C coordinate vector of the vectors in the basis C. So these are the basis of the base vectors in the basis B, but you want to write them in C coordinate. Okay, so that's the notation. And how do we do it? So this is the picture. So B is called a change of coordinate matrix. B to C is a change of coordinate matrix from B to C. When you write it in the sentence, you write B to C. When you write it in the notation of the matrix, you have C come first, and there's a reason for it. Okay. So here, this is the formula. So just need to remember this formula. So you can think of B, starting with B, you have the vector in B. You change it to C, so it becomes an X vector in terms of C. And so how do I find it? So it's earlier we say, oh, it is found by writing all of them in terms of writing all the B vector in terms of C. So it can be found by doing an RREF or row equivalent of changing the first the C vector into the identity vector because that is the inverse, right? That's the inverse. And the second part will become a B to C change of coordinate vectors. So this is how you do it. So let's do an example. For example, I have two bases for a vector space. B1 is negative 9, 1. B2 is negative 5, 1. C1 is 1, negative 4. Okay, blah, blah, blah. And they are both bases. They are independent and they span a vector space V. I want to find the change of base matrix from B to C. So change of base matrix from B to C would actually write all the C vectors. So that's the reason why they write it backward because the C vectors in standard matrix form is written in the front. And then the B vector negative 9, 1, negative 4, negative 1 here. And then you do an RREF. If you do RREF, the first will automatically be changed to I. So I have written it in my matrix calculator. So 1, negative 4, 3, negative 5, negative 9, 1, that's my A. And I do REF of A. It become 1, 0, 0, 1, 6, negative 5, 4, negative 3. Oh, 6, no, 6, yeah, 6, negative 5, 0, 1, 0, 0, 1, 6, negative 5, 4, negative 3. So this is the reduced echelon form of this all the bases line up, and this will become C to B. So we'll say it is equal to 6, 4, negative 5, negative 3. So if you have a vector that's written in terms of B, you multiply this in the front, it would become a vector in terms of C basis. Another example, and this is an example, we will actually do the change of base vector and of both C to B and B to C, and also change a particular vectors that is written in B to C. So which one should we use? Okay, so to find a change of base matrix from C to B, I write it like this, right? B is our answer, so this would be writing the B in the front. 1, negative 3, negative 2, 4, negative 7, 9, negative 9, 7. And then I do a RREF to change the first into right, so 1, negative 3, negative 2, 4, negative 7, 9, negative 5, negative 7. If I do B, reduce row echelon B, it's 5, 6, 3, 4. 1, 0, 0, 1, 5, 6, 3, 4. So the actual, so this is the work, the actual one, well, I should not say equal. So is the actual one is actually 5, 6, 3, 4. Okay. What about the change of coordinate vector from B to C? So if I want to do from B to C, I have two ways I can actually do it reverse, right? By write the C in the front and write the B in the in the back and do REF. But actually a faster way is actually just do 5, 6, 3, 4 inverse. They are inverse of each other. Because yeah, if you want to change it back, you just do inverse. So matrix in C is equal to the change of base from B to C, right? So that would be x of x in terms of B. And you can see that if you want to write it in B, I write it in front like that, then you would just do probability of C to be inverse, right? X of C. And this is actually equivalent to the not probability, the matrix from B to C, right? You start with C and you get a B. So you can just do this inverse. I don't have it. So what? 5, 6, 3, 4. 5, 6. Yeah, because I haven't find it. And then I would say E inverse. So 2 negative 3 over 2. Oh, 2 negative 3, negative 3 over 2, 5 over 2. So it's 2 negative 3, negative 3 over 2, 5 over 2. Okay, here's the last question. They say, or the application, what is C if I have X of B? Which one should I use? Well, I have B. I want to change it to C. Of course, I want to use this one, right? Because I'm given B. So I would write it out. So X of C is actually equal to change it to from B to C of X of B. So that is the one that we have earlier, 2, negative 3, negative 5 over 2. No, is it 3 over 2 or negative 5 over 2? Negative 3 over 2. And then 5 over 2 times my x of b, which is negative 2, 1. So if I write negative 2, 1 in terms of b, if I want to write in terms of the new basis c, what would it be? So I would have to multiply, I need to do another matrix, right? I need to multiply negative 2, 1. So just negative 2 and 1. Then this one I would say multiply with f. There is negative 11 over 2 and 17 over 2. Negative 11 over 2 and 17 over 2. So when you do your worksheet, just pay attention to what are you changing. Okay, so it's very clear. So because you multiply the coordinate of b, so this 2 has to match. And then if you change it to c, this becomes c. And this is fine by writing c in the front and b in the back for the basis and do RREF. Okay. So I have another. Do I have enough time to do this last one? Okay, I'll do it in the next video. This is really short, but I don't think I can finish in 2 minutes.